Good morning, class. So today we hopefully will be wrapping up analytical geometry, so we can enjoy our weekend with something else. There we go. Yes, I didn't want to say it, but yes, with that. Okay. So at this point in our lives, we were busy with exercise 11.3. So we're done with this page here. No? We did all of this here. Oh, no, here's 11.3. You were just saying yes. You see, I just spoke to you people now. Now, next year comes is a grade 10 learner. He's going to say, but sir, I didn't understand number 3. But I say, but you know that grade 10 class, they did really well when they were grade 9. They had no problem. That is why it wasn't in the video. Don't just say yes, yes, yes. But also don't give me a whole lot of numbers. There was a girl. No, I'm not going to mention her name. I remember her very well. Also grade 10.
Is it me, sir?
Not you. She was in grade 10. The girl was at our school. So she also said, so I said, please give me something. Let me do it on the board. Because I know it's a section, trigonometry. I know it's a section that learners have problems with. So she shouted from the back. She's sitting there somewhere at the back. Just give her any number, man. The next term she was in maths lit. Okay. So people. So listen, don't be like her. No? Right, listen. I'm sure you guys are not like it. Okay. Any problems with number 3? No. Okay. Let's carry on. Number 4? Yes. Right. What's the problem with number 3? Everything. Everything in your life is an issue. Okay, so let's look at number 3 quickly. We are told that ABC are vertices. So I'm not going to draw the triangle in the quadrant. I'm just going to do it as follows: AB, or the Cartesian plane, C, which is 1 and negative 5. Definitely you'll get a better representation of what's happening if you had to draw it on the Cartesian plane. Okay. So on the mid, the R, S, T are the midpoints respectively. So R corresponds with AB. So R respectively means to say in that order. So AB, there's R. S, which is BC. And we have AC to be T. Okay. A says, calculate the coordinates of. Now, if that's the midpoint, we use the midpoint formula. Not so. Okay, with R, is x1 plus x2 over 2, y1 plus y2 over 2. So we go R. If you make this x1, so it's negative 3 plus negative 5 over 2. And 1 plus negative 3 over 2. So R gives us negative 4 and negative 1. You would agree with that? Then for S, again that is a midpoint. Why am I making that 2 strokes and that 1 stroke? Because they are different. Okay? So S, again x1 plus x2 over 2. So it's for BC, B and C, so it's going to be 1 plus negative 5 over 2 and negative 5 plus negative 3 over 2. So S, sorry man. Hello? Speaking? I'm in a class now, man. I'm in a class. You can call me after 4 today. Yeah. Okay. No problem. Bye. So for T, again x1 plus x2 over 2. It's negative 3 plus 1 over 2. And y1 plus y2 over 2. So it's going to be 1 plus negative 5 over 3. So t works out to be negative 1 and negative 2. Okay. People, what? Okay, and that's also the midpoint here. No? What would happen if I draw that line there? What could be concluded about this? If I had connected R and S. Sorry? The midpoint here. Can you see the midpoint here? Then what could we have said? That AC is equal to twice RS. Not so? Why? Because this is the midpoint that's connected. What else can we say? That RS is parallel to AC. Why? You have the midpoint here. Okay, and many other things you could have done. From that information we can conclude the midpoint. But that wasn't the question. No? Then it says calculate the length of CR. So, how do we calculate length? Distance formula. Not so? So B, so CR is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. So C is 1 and negative 5 and R is negative 4 and negative 1. Not so? So CR, this line here, is what we calculate. So that will simply give us the square root of 1 minus minus 4 squared plus minus 5 minus minus 1 squared. That gives us the square root of 5 is 25 and 4, 16 is 39. Is that 29? No, that's 25 and 16, 39. Is that correct? Sorry? 41. Oh. Yo, how's my adding? 41 is good. Okay, you guys understand? Then you go for AS. Same story. So AS is this line here. It's going to be negative 3. What is S coordinates? Negative 2 and negative 4. AS is negative 2 plus, no, minus. Okay, so it's plus. So it's negative 2 plus 3 squared plus minus 4 minus 1 squared. So that is 25 and 1 is 26. Is that correct? Yes. And then that's now the distance. Distance, the thing on top means distance. No? BT, which is that length there. Again, same formula. I just write it once down in the equation. So negative 5 minus minus 1 becomes plus 1 squared plus minus 3 plus 2 squared. So it's going to be 4 squared, which is 16, 17. So the root of 7. And do we write it in decimal? No, we leave it in simplified circle. We could, if you wanted, you can write in decimal, but you won't gain anything extra, okay? But normally the sum would read, in this part of the work, it would read, to leave your answer in simplified circle. So if you put the root of 50 in a calculator, you get 2 root 5. No, 5 root 2, sorry. Okay, but that's we do in grade 11. Okay. And number 4, show that these are vertices. Show that A, B, C, and D are vertices of a parallelogram by using the fact that the angles of the parallelogram bisect each other. So what are we supposed to be doing there? Working out the midpoint. Not so. But if we look here, so there's A, which is negative 3 and 2, B, which is 3 and 6, C, which is 9 and negative 2, and D, which is 3 and negative 6. Okay? So what you do is you work out the midpoint here. Let's call that M for now. So the midpoint of using AC, the midpoint of line AC is going to be again x1 plus x2 over 2, y1 plus y2 over 2. Okay, so it's going to be negative 3 plus 9 over 2, and 2 plus negative 2 over 2. So that gives us 6, which is 3, and 0. Now you got the midpoint of DB. You get the same story. You'll get an answer of 3 and 0 there. So since the midpoint of AC and the midpoint of BD are equal, therefore the diagonals bisect each other in a rectangle, in a parallelogram, therefore it has to be a parallelogram. Okay, that's the exam type question there. Question 5. It's also a common asked question, question 5. Let's pull this down here. Question 5, we are told that S, which is x and y, is the fourth vertex of parallelogram PQRS. The fourth vertex of parallelogram PQRS. Given that P, which is 2 and 6, Q, which is 8 and 4, R, which is 4 and 0, determine the value of x and y. So what we have here, something looking like this. So S is the fourth, let's just put it here, it doesn't have to be there. It could have been in any corner there, or the 4 corners. The fourth vertex of parallelogram PQRS. There's PQRS in that order. Order is important. Given that P, which is 2 and 6, again you could have drawn this on a Cartesian plane, but I've given you a better representation of what is happening here. Okay? But in the exam, normally the diagram is given. If it's not given, you draw it on a Cartesian plane, and that will give you a sense of your answer is correct. Okay? But because I want to get through this here, so I'm not going to draw it on the Cartesian plane. The question is to work out, to determine the coordinates of S, or to work out the value of x and y. So if this is a parallelogram, we know that it shares a common midpoint on your diagonals. Not so all your diagonals bisect each other. So what I do is I work out the coordinates of the midpoint. Again, let's call this M for now. So M is going to be the coordinates of midpoint PR is going to be x1 plus x2 over 2, y1 plus y2 over 2. So again, if you make this x1, that will be y1. If this is x2, this will be y2. You all understand? No? So that would simply be x1 would be 2 plus 4 over 2, 6 plus 0 over 2. Okay? So the midpoint of PR is going to give you 3 and 3. Can you see that, people? So if we go the other way now, what do we have now? Okay, just remember this was the midpoint. So now we have a line looking like this. We've got Q, which is 8 and 6. We have the midpoint, which is 3 and 3. And we need to work out S, which is x and y. Can you see that, people? You will understand. So what can we say? This is x1, y1, x2, y2. This is the formula we're going to use again. Okay? So if x1 is now x, can you see x1 plus x2? So it's going to be x plus 8 over 2 is equal to 3. Whatever the x coordinate is there. And then y plus 6 over 2 is going to give you, or this 3 now, whatever value is there. Okay, this by chance that both is 3 is not always 3. Not always the same, sorry. So 3 times 2 is 6, so x plus 8 is equal to 6. So x is equal to negative 2. You cross multiply here. So it's y plus 6 is equal to 6, so y is equal to 0. So if they had asked you for the coordinates of s, s would have been negative 2 and 0. 2 and negative 2. How you get negative 2? And you got negative 2. Yeah, the textbook's answer. 10 and negative 2.
No. The textbook's answer is 2 and negative 2.
2 and negative 2. Who got 2 and negative 2 in their answer? Okay, somebody got it. So that is 3 and 3, that's correct. Negative 2 is 6. I think I'm correct. Right, Faye, how did you get that? You got this, the midpoint to be 3 and 3. Right, so this is right. Okay? Then what did you do from there, Michael? X is yes plus
equals 3 over 1.
3 over 1, yes.
And then I cross multiply.
Yes.
And then I say x is plus 8 is equal to 6. And then I said x is equal to 6 minus 8, then x is equal to negative 2.
Yeah, so it makes that right, yes.
And then for the other one, I said y is plus 4 is equal to 3 over 1.
Now I have 4. Is it Q 6? 8 and 6? Oh, that's my mistake. You see, it's 8 and 4. It's 8 and 4, not 8 and 6. That's my mistake. Can you see here? That's supposed to be 4. You cross multiplied 6. Take it over. So it's 6 minus 4 is 2. So that's supposed to be. You see my mistake? I wrote the coordinates down wrong from here. Okay. Thank you, Michael. Alright. Question 7. Question 7, we are given this scenario here. A, which is x and y. B, which is 8 and 4. C, which is 7 and 11. And D, which is 2 and 6, are vertices of quadrilateral. Where 6? Oh. Okay, we'll talk about question 6 later. Alright. The diagonal AC bisect BD, which means to say this length there is equal to that, whilst that is equal to that. Okay. They want you to work out the coordinates of A. Well, as I just did now, you can work out A. Not so. Let's put here number 7. So in A, it's going to be x plus 7 over 2 is equal to 5. And then y. What's wrong? Y plus 11 over 2 is equal to? It's equal to what? Y, we're working out the coordinates of A. It's equal to 5. Over 1, so you cross multiply, so y plus 11 is equal to 10. So y is equal to negative 1. Cross multiply, so you got x plus 7 is equal to 10. X is equal to 3. So therefore A would be 3 and negative 1. Okay. Now you see, does this make sense for x to be 3 and negative 1? Yes. The 3's are the positive part of your x-axis, and the negative 1 is below the x-axis. That is why it's beneficial to write or to draw the quadrilateral in its correct with respect to quadrant. Okay, so we're looking at B. B is to show that ABCD is a rhombus. Okay, so which diagonals bisect each other firstly? So that could be, as it stands there, it could be a parallelogram. No, that's a DC, could be. Okay? Which other quads diagonals bisect each other? Rhombus, square. They bisect each other equally, but in this case would have been that. It would be the rectangle as well. No? So any of those four. So for the least it would be a rectangle, a parallelogram. So if they'd asked you to prove this a parallelogram, that would have been enough. Okay? But they're saying a rhombus, so there's a special parallelogram. Not so? So, of course you must now prove another property that is evident there. So if you've got a square, you see it could be a square, a rhombus, a parallelogram, and a rectangle. No? So it's already a parallelogram. So which property would we find in a rhombus that is not in a parallelogram? That's the question you should be asking yourself. Sorry? What do we know of a rhombus that's not in a parallelogram? What's the properties of a rhombus? Sorry? All sides are equal? Opposite angles are equal? So that's in a parallelogram already? Sorry? Sorry? Diagonals bisect each other? Diagonals bisect the vertex angle? There's one more? Or two more? The 90, yes, that's the one I'm looking for. What about the 90? Diagonals are perpendicular. So if I can prove that that is the case, then it could be a rhombus. Or I could work out the lengths here. I can work out all the lengths and show that all the lengths are equal, then it could be a rhombus as well. You guys understand? So the easier of the two calculations is what? To prove that that is going to be 90 degrees. Can you see that, people? And how do I prove that two lines are perpendicular? By working out its gradients. Not so. So I work out the gradient of the one line, which is AC. How do you work that out? So it's y2 minus y1 over x2 minus x1. Okay. So for A, it's going to be 3 and negative 1. C, which is 7 and 11. Or I could have used TC. Or I could have used TA. It's all the same. Okay? Why? Because these points are collinear, which means to say they lie in the same line. The line in the same line, it has the same gradient. Okay. So if this is x1, y1, x2, y2. So we go with this formula, so it's going to be 11 minus 1 over 7 minus 3. Nope. 7 minus 3. It's a 3 and not me. So that simply gives us a gradient of 12 over 4, which is 3. So the gradient of that line of AC is going to be 3. So if we can prove that the gradient of DB is negative a third, we've done the job. Not so? Why? Because the product of the two gradients is negative 1 if lines are perpendicular. If lines are perpendicular, the product of the two gradients is negative 1. So let's go with that. The gradient of BD. Okay, so we go B, which is 8 and 4, and D, which is 2 and 6. This is x1, y1, x2, y2. So it's going to be 6 minus 4 over 2 minus 8. 6 minus 4 is 2. 2 minus 8 is negative 6. So it's negative a third. That's what I wanted to have been. So what do we say now? Since, yes? Since the gradient of AC times the gradient of BD is equal to 3 times negative a third, which is equal to negative 1. Therefore, a BD is perpendicular to AC. Alright? So since the diagonals are perpendicular and the diagonals bisecting each other, therefore AB CD is a rhombus. Why? So you then why? Because firstly the diagonals bisect one another and the diagonals are perpendicular. So rather write diagonals are perpendicular. So that is enough to conclude a rhombus. What other shape is that information evident in? Is a rectangle. So the gradient of BD. Not a rectangle. The rectangle's diagonals don't bisect each it's not that perpendicular. It's only in a kite square, eh? Rhombus. Could that be a kite? No, why? So the diagonals don't bisect each other in a kite. Can you see that? So this couldn't be that. So if the only other shape this could have been is a square. So then ask us to prove this is a square, I have to go another step further. Am I going to talk about the sides that are equal there? No. So it was still in the rhombus. Even if they had asked us to prove from here it was a square, then I would have proved that is also 90. Can you see that? It would have then been a square. Just coming back to number 6. Just clear this here. Okay, number 6. We show that a TSRP is a rectangle. Okay, so now I'm not going to do this now because we don't have much time left. But for this to be a rectangle, okay, well, what's the property of a rectangle? Is that the diagonal, opposite two pieces of opposite sides are equal. But by proving these opposite sides are equal, then the least it could be is a parallelogram. Not so. So you first work out those lengths. Okay? Then, what do you think we're going to prove then or thereafter? The 90 is. Then one of these vertex angles are 90. Okay? So if that is 90, then that means to say it's perpendicular. Then in conclusion, it's a rectangle Y. Two pairs of opposite sides are equal. And the vertex angle is 90. Therefore, it has to be a rectangle. You understand? So, that's the approach you will do on that one. Let's just carry on here. We spoke about gradients of lines. Now we see there was a mistake there. It was delta Y with delta X. Okay? Then we did... we spoke about parallel lines, perpendicular lines, no? Then we did an example. Spoke about that. So now we can delete this page. Then we went on to 11.4. Correct?
Yes.
What needed to be done out of 11.4? Right. Calculate the gradient of the line joining. So this exercise 11.4. And this was on page. Sorry? What? 521. The girl just gave me a page now. Remember the story I told you at the beginning of the lesson? The girl just gave me a number. Don't be like her, no? Right? You have to do number 1. All 5 sums.
Yes.
Right. Any issues with number 1?
If.
If. Any issues prior to if? No. So the gradient, this is now if, no? Calculate the gradient of the line joining these points. So the gradient of, how you work out gradient? y2 minus y1 over x2 minus x1. Or you guys use m is equal to yb minus ya over, no? Yeah, it doesn't matter, it's the same thing. As long as if you go ya minus xa, this must be, sorry, yb minus xb, this must be xb minus xa. No? Am I saying it right? Yb minus ya must be over xb minus xa. Or if you go ya first, ya minus yb must be over xa minus xa. You see that? That's important to know. Okay. So if you make this x1, y1, x2, y2, so it's going to simply be minus 2b minus b over negative 2a minus a. Minus 2b minus b is minus 3b over minus 3a. So it's going to be b over a. And that is the reason why they say where a can't be equal to 0, otherwise the sum will be undefined. Okay, if b is equal to 0, the gradient will be 0. Okay. Determine the gradient of the line perpendicular to each line in question 1. Right? So since we got the gradient of if lines are perpendicular, what do we know? M1 times M2 is equal to? Negative 1. Okay. So this would be the gradient of the first line. Not so. So it's then going to be b over a times the second gradient is going to be minus 1. How do we get the second gradient on its own? Divide by b over a both sides. Not so. So m2 is equal to negative 1 over 1 multiplied by its reciprocal, which is a over b. So that is simply negative a over b. Okay. And that's how you do it for all of them. Okay. In question 3, question 3 says, any issues with question 3 before I go into it? No problems. So you worked out the gradients. Which lines are parallel? A and C is parallel. No? These lines are parallel, perpendicular. Is A perpendicular? Now who's giving us the wrong answer here? So, okay, which lines are parallel to each other? B? Just B is parallel. So that means to say that the gradient of AB is the same gradient as CD, once you have worked out. No? Which lines are perpendicular? Sorry? A is perpendicular. Which means to say that the gradient of AB times the gradient of CD gave an answer of negative 1. Right. And C? Neither, okay. So C was neither. What about D? Neither. Right? Good. And E? Problem. Okay, no problem. I'll do E. Number 3E. Alright. So, what's the question? You must determine if the lines are parallel, perpendicular, or neither. If you're talking about parallel, perpendicular, they refer to the gradients being equal when it's parallel. When you multiply the two together and give you an answer of -1, it is perpendicular. So we first work out the gradient of AB, which is y2 minus y1 over x2 minus x1. Okay, so if you make that x1, y1, x2, y2. So it's going to be kb minus b over ka minus a. What do you notice? What is common on top? The b. What are we left with? K minus 1. What's common at the bottom? A. So I'm left with K minus 1. So hang on. You cancel. It's B over A. Not so? Let's see what's going to happen when we do the gradient of CD. We get the gradient of CD. So again, that is x1, y1, x2, y2. So it's going to be A minus PA over PB minus B. So what do you notice there? A is common. Take A out as a common factor, what do we left with? 1 minus P over, what's common in the denominator? B. We are left with B minus 1. So what I do is I swap this around here. Why do I swap it around? So you can cancel the denominator. If I swap it around for the negative, what's going to happen? Negative comes out. Not so? I could have swapped the denominator around, doesn't matter. No? But I'm not going to swap both around. Okay, otherwise you will be on square one again. So that cancels. So what are we left with? Negative A over B. So what do you notice here? You can multiply them. Not so? And this is how you conclude this. Since the gradient of AB times the gradient of CD is equal to B over A times negative A over B, which is -1. So therefore, AB is perpendicular to CD. Now if those lines were, if these gradients were equal, then the lines would have been parallel. Can you see that, people? This must cancel, no? Those of you checking, hey, this is -1. Okay? Do you guys understand? Right. Let's look at the next example. Now we've got 1 minute left. Or 5. Right, which page are we on, people? 257. 257. Gradients, here we go, 257. We spoke about that example, Collinear. This is the one thing we still need to do. And this one, okay. So we're on page 256. Example on page 256. Okay, so in example 3 on page 256, we don't have much time, so I'm not going to give you a chance to do it, but just follow what I'm doing. Okay. It says determine the point D in each if the point A, B, C, and D are given by A, which is negative 1 and 3, B, which is 2 and 4, C, which is 6 and 0, and D, which is X and Y. So, for us to determine the point D, I must just work out the value of X. Not so. We work out the value of X. So, in the first case, if lines are parallel, what do we know? Let's call this one. If lines are parallel, what do we know? Gradients are equal. So, the gradient of AB must be equal to the gradient of CD. Not so. Gradient of AB must be equal to the gradient of CD. So, what I do is, I first work out the gradient of AB. The gradient of AB is y2 minus y1 over x2 minus x1. So if this is x1, y1, x2, y2, then that would simply be 4 minus 3 over 2 minus 1. So that's going to give you 1 over 3. Are you all okay with that? Then the gradient of CD. But now I'm going to work out the gradient of CD in terms of x. Don't write now, look here. Now I'll take a photo of it. So the gradient of CD, so it's going to be 4 minus 0 over x minus 6. So that's going to be simply 4 over x minus 6. But if you had gone the other way around, you would have said 0 minus 4 over 6 minus x. It would have given you negative 4 over 6 minus x, which is the same as this. You all agree with that, no? So now coming back to what they want here. They want the lines are parallel. So if lines are parallel, what do we know? Gradients are equal. So what's the first gradient? 1 over 3 is equal to 4 over x minus 6. So what do we do now? Cross multiply. That's going to give you x minus 6 equal to 3 times 4? 12. So x is equal to 18. Do you guys understand? So let's look at it again. AB is parallel to CD. Lines are parallel, gradients are equal. I work out the gradient of AB and I work out the gradient of CD in terms of x. I then say, if lines are parallel, gradients are equal. The first gradient is a third, has to be equal to the second gradient, which is 4 over x minus 6. Okay. Coming to this other one here on this side, if lines are perpendicular, what does that mean to say? The product of the two gradients is negative 1. So the gradient of AB times the gradient of DC is equal to negative 1. What's the gradient of AB? A third times the gradient of CD, which is 4 over x minus 6 equal to negative 1. So what do I do first? Divide it by a third to get the one fraction on its own. So it cancels. So 4 over x minus 6 is equal to negative 1 divided by a third is negative 3. Okay. So what do I do now? That's naturally over 1. What do I do now, people? Cross multiply. So that's going to give you 4 is equal to negative 3x plus 18. Negative 6 times negative 3 is 18. Not so? So you solve for x. You take the 4 over and that over. So 3x is equal to 18 minus 4, which is 14. Therefore x is equal to 14 over 3. You guys understand? People, in the next example, which we don't have time for, they ask us to prove that lines are, or points are collinear. Collinear means to say it lies on the same line. If points are collinear, that means to say that if you got A, B, C, points are collinear, then the gradient of AB is equal to the gradient of BC, which is equal to the gradient of AB, BC, and AC. You understand? So if they ask you to prove that line points are collinear, you prove that the line, the gradients are equal. So for homework, I'm going to send you the photo of this now. So for homework, I would like you guys to do number 4 to 8 of exercise 12.4. 4 to 8 of 12.4. Did I give you check your skills for homework already? This year? Okay, this you can do on your own. I don't expect you to hand in this, okay? So that you can do on your own time. If you have a problem, you bring it to me, okay? People enjoy the rest of your day. Good morning, class. Bye. Enjoy the rest of your day. Salam.